In our third example, we are doing another example of just combining and how we change that. So in this example, every spring at good old Podunk High School, the Math Honor Society hosts a trash tournament. For this tournament, male and female contestants are randomly paired up as teams. Trash by the way, would be where you compete in throwing balls of paper into trash cans. Super exciting sport. The means and standard deviations for the heights in inches of the male and female contestants are given in the table below. So for males, the mean height is 69.5 inches, the standard deviation of 3.2 inches. For females, mean of 65 inches with a standard deviation of 2.8 inches. So our first part of this is finding the probability that a female contestant is paired with a shorter male. So when we're talking about shorter versus taller, that's not necessarily combining their heights. Adding together the female and the male's heights is not really going to help us here unless we were like having the females stand on top of the males in the trash ball tournament. It's not really a thing. Because we're talking about a comparison, shorter, taller, what we're really looking at is a difference in height. So in this example, I'm finding what is the probability that the difference in their heights, female minus male, is greater than 0. If the female is taller than the male, which is what we're trying to find the probability of, then when we subtract the female's height minus the male's height, we would get a value that is greater than 0. So the female is taller than the male. So that's what we're finding. We could also find the probability that male minus female is less than 0. Either one of those would work just fine. And in fact, doing it this way means you're going to be dealing with fewer negative numbers, since in our actual numbers, the male mean is bigger than the female mean. So doing it this way will have you dealing with less negative numbers. But you should get the same answer either way. So it's just kind of up to you on what you want to do. I'm going to do it this way, but again, we could do it either way. So the first step in this, that's what I'm going to do. But the first step in this is to find the mean and standard deviation. So I'm going to do that over here. So the mean of male height minus female height. Again, expected value. We do exactly what we expect. So 69.5 minus 65, which is 4.5 inches. So on average, males are 4.5 inches taller than females. And then for our standard deviation, right, of male minus female. So as always, we can't just add or subtract standard deviations. We have to deal with variances, just like always, when we're combining two different random variables. But it also, one of the things we learned last class is that we are never actually subtracting. Variance or standard deviation is always going to increase when you're combining two different random variables that have their own standard deviations. There's always an increased amount of variation. So we are still adding, and we're doing our variance square rooty thing. So I'm going to do 3.2 squared plus 2.8 squared to get the combined variance. And then I'm going to square root that to get back to standard deviation. And that will give me a standard deviation of 4.25 inches. Both of these are inches. So on average, males are 4.5 inches taller, but that standard deviation and the difference in height is 4.25. So that's our mean and standard deviation. Next step is we are going to normal model. We are assuming, I think it says it somewhere on your paper, perhaps later, but it does tell us that male and female heights are normally distributed. So the combined is still normally distributed. So again, we have our mean 4.5, 3 standard deviations-ish either way. Don't be concerned. If we go 1 standard deviation, we're already at 0.25, which means going 2 standard deviations to the left is going to be into the negative. But that's okay, because remember, we're talking about a difference in heights. So sometimes when you subtract 2 heights, you're going to get a negative number, just depending on which way you subtract it. Sorry. So now we're finding that probability. So the next step would be to find a z-score. My observed is 0, because that's where I'm kind of drawing a line. I want to find where that difference in heights is less than 0. So 0 is my observed minus the mean of 4.5 divided by my standard deviation, 4.25. And then I get a z-score of negative 1.06, so a little over 1 standard deviation below the mean. And we were finding where it's less than 0, so I'm going to shade to the left. And then, as always, I'm going to use either my z-table, or you can use your calculator if you would like to find that proportion or probability. So I'm going to use, again, the z-table or the calculator. Second bars, I'm going to use -1 E99 as my lower bound, and then I'm just going to put my z-score as my upper bound, and that'll give me real quick that probability. So there's a 0.1446% or chance, so a 14.46% chance. So almost 15% chance that the male will be shorter than the female. I was kind of pointing out on calculator, doing it this way is not something I've talked about before. When we first learned calculator back at the beginning, I showed you where you would just put the numbers in there to begin with. So you could have done this. -1 E99 is my lower. My upper is 0, because I wanted to go all the way up to 0. And then I could have typed in the mean and standard deviation. And that should have gotten me an answer that's fairly close. You'll notice it's not exactly the same. This is actually a more exact answer because the calculator is not rounding with the z-score. But if you know the z-score already, and remember you always have to show all of your work anyway, doing it the way I did earlier, where you just put your uppers, your z-score, and you leave the mean and standard deviation alone, will give you a real quick probability. So just wanted to point that out.